So we are told to find the direction cosines of vector A, and for part B we are told to find the vector projection of vector B on vector A. So for part A we have vector A, which is 3, 1, and 2, which we can label as A1, A2, and A3, which is going to make it easier when we find the direction cosines of each component. So for cosine of alpha, we have A1 over the magnitude of vector A. For cosine beta, we have A2 over the magnitude of vector A. And for cosine lambda, we have A3 over the magnitude of vector A. So we can find the magnitude of vector A by doing the square root of each component squared. So we have 3 squared plus 1 squared plus 2 squared, which gives us the magnitude of A as the square root of 14. So then we can plug in 3 over the square root of 14, 1 over the square root of 14, and 2 over the square root of 14. To find each direction cosine, we have to do the inverse cosine to get rid of the cosine on the left side and leave the alpha, the beta, and the lambda symbols by themselves. So then we have alpha equals the inverse cosine of 3 over the square root of 14, which gives us 36.7 degrees. And we have beta equals cosine inverse of 1 over the square root of 14, which is 74.5 degrees. And then we have lambda, which is cosine inverse of 2 over the square root of 14, which gives us 57.7 degrees, which answers part A.